Okay, so we just labeled what we know. So we know that there are 6 bottles, and in each bottle there is 9/10 of punch, 9/10 liters of punch. And so I'm going to put my liter symbol beside there. All right, what do we do next in our 4 block, Judy? We draw a picture, okay? Now, what kind of picture do you think we should draw for this problem? What would be appropriate, Joseph? Tape diagram. So when I draw my tape diagram, how many ways should I partition it? 6. Because why? Because we have 6 bottles. Very good. So let's draw a tape diagram, and we're going to partition it into 6 equal parts. So I'm going to split it in half, and then each half in thirds. Does that make sense? So each one of those parts represents a bottle. What do we know about what was inside those bottles? 9/10 liters of punch. So what will I put inside each part? 9/10. Okay, very good. All right, what goes in my 3rd box? Always. Mackenzie? What are we solving? How many liters of punch did she pour in all? Do you see any keywords there? In all. What does in all tell us? Joseph, you were on it today. Huh? Well, it tells us we can either add or, hey, in all tells us we're finding a total. And we have learned anytime you're finding a total, Sinai, table 3, that you either add or multiply. Now, you multiply when you have equal groups. What clue word did I tell y'all is an indicator of equal groups? Each. If it says there were this many and there was this much in each, that's an equal groups problem, because look, don't we have groups here? Isn't there the same amount in each container? That is an equal groups problem, okay? Because there's the same amount in each group. And when you have equal groups, you can what? Multiply. Now we could add 9/10 plus 9/10 plus 9/10 and so on. Or we could do it more simple and what? Just multiply. How many times would I have to add 9/10? 6 times. So instead of adding 9/10 6 times, what multiplication number sentence could I write, Colton?
The multiplication number sentence of which 9 is 9/10 times 6.
Okay, I'm going to do my whole number first. 6 times, or 6 groups of 9/10 equals. Okay? So write that on in your box. All right, so when we're doing a problem like this and we're taking a whole number and multiplying it times a fraction, Yasmin, what do I do first?
What we do first is we see what 6 times. 1 second.
Go ahead.
What we do first is we see what 6 times 9 is.
Exactly. We take our whole number and multiply it times the numerator. What is 6 times 9? 54. What happens to the denominator? It stays the same. So 54 tenths. What do you all know about 54 tenths? It's an improper fraction. What does it mean when I have an improper fraction? What am I talking about, Christopher? Very good. It means the numerator is greater than the denominator. Okay? So let's ask ourselves, will 10 divide into 54 evenly? No. So that means we have to do what then? We need to number bond it because we're changing that improper fraction to what? A mixed number. Okay? So 54 tenths. So let's ask ourselves, how many times will 10 go into 54? 5. So how many wholes can we pull out? 5. Very good. Now what's my fraction going to be that equals 1 whole? 10 tenths. Remember, let your denominator guide you. So I'm going to pull out 10 tenths 5 times. And if you want to, you could go ahead and label your wholes, couldn't you? How many am I pulling out? 5. Good. Because 10 will go into 54 5 times. So if I pull out 5 10 tenths, how many tenths is that altogether? 50. Now we have 54 to begin with. If I pull out 50, how many are left over? 4 tenths. Now because we're changing 54 tenths to a mixed number, we need a whole number, don't we? Because a mixed number is a whole number and a fraction. So what will I do next? Naomi, what will we do next? Exactly, how will we do that? We're going to label the wholes, right? So if you have not done that, label your wholes. So each fraction that equals 1 whole, I'm labeling it. How many did you label, Journey? 5 wholes. So our answer would be 5 wholes and 4 tenths. Now, what do we do before we finalize? We ask ourselves, can 4 tenths be simplified? Yes, and we worked on that earlier, didn't we? 4 and 10 are both what? Even. And remember, Jacob, anytime you have a fraction where the top and the bottom are both even, you can simplify. So what are we going to have to write the factors of? 4. So I'm going to write the factors of 4, starting with 1. So 1 times, and then 2 and 2. Is 3 a factor? No. And then we already have 4, right? So that tells us to stop. Okay? All right, so we try the largest first because we're looking for the
Greatest common factor.
very good, greatest common factor. So we know 4 goes into 4. Does 4 go into 10 evenly? No, so I'm going to exit out. All right, now we go to
2.
why, Bria? It's the next greatest. So we know 2 goes into 4 evenly. Will 2 divide into 10 evenly? So that's our greatest common factor. So what do I do with that 2? We divide the numerator and denominator by the greatest common factor, which is 2. 4 divided by 2? 2. 10 divided by 2. Now don't forget about your whole number. So our final answer would be 5 and 2/5. And I don't have a whole lot of room, so I'm going to write that right here and circle it. Okay? All right. We're not closing our notebooks. Tomorrow we will solve those 2 together, okay? Because in real life, guys, you're not going to be sitting around doing problems like this, okay? The 8 times 3/4. In real life, you're going to deal with scenarios like in these word problems. On tests that you take, on standardized tests, benchmarks, integrated tests, things like that, you're going to deal with these kinds of problems, not 4 times 1/3, okay?